Math paper 1 class. This is a senior 5 math paper 1 class, and we are going to get started as soon as possible. Let me request Bridget to give us a word of prayer as we get started as soon as now. Bridget, are you there? Okay. Bridget? Okay, give us a word of prayer, Bridget.
Let's humble ourselves for a word of prayer. Heavenly Father, we thank you for the gift of the new day. We thank you for our lives. Thank you because you've protected us. Men have died, but you are still alive. Thank you so much for our teacher. We pray that you be with him, be upon him, so that we can understand whatever he teaches, and also help us understand and not forget whatever he teaches. In Jesus' name I pray and believe.
Amen. Thank you, Bridget, for the prayer. And as our friends are keeping on dropping in, as our friends are keeping on coming in, we could start right. Start right away. Okay, so we've been looking at the binomial theorem, and we've done quite a lot. Today, I want us to quickly summarize through with a lot of worked examples. We are going to do quite more worked examples as far as the binomial theorem is concerned. And before we carry on the worked examples, I'm going to go through something that we were trying, most people were asking in our previous lesson, that we had about three formulas that we had worked on, and a couple of people were asking, how do we work out, when do we use a certain formula, and then at what stage do we use a certain formula? And I'm going to first go through that in a little while before we get started. Now, to start with, when do we use these given formulas here? That's what I want us to start with. So one, I'm going to start with the first one. Now, we had this formula here where we said if you have a plus b to the power of n, you can say we have the summation from r equals to 0 to n. Then we say n combination r, then a n minus r, and then b to the power of r. Now, I want to start with this one here. When do we use this one here? When your power is a positive integer, okay? When your power is any positive integer, for example, if n is ranging usually from 2 onwards, positive, like 2, 3, 4, 5, extra, etc., etc. In such a case, we use this one here. Okay, so here I'm emphasizing that for any positive integer, this is what we are going to use. The integer is a power, okay? The integer is a power. That is when we use it, okay? So this is the very first thing, the first part that we are looking at. Now, in addition to this one here, also for positive integers, okay, for positive integers also, we utilize this one as well, where we said 1 plus n combination, 1 plus n combination 1, x plus n combination 2, and so on and so forth. Now, you realize that when you have the combination part of it, for example, when you have n combination, the combination is only and only working for positives. Okay, so only when you have positives, that is when you're going to utilize the combination part of it. Negatives you're not going to use the combination. Why don't we use the combination in negatives? Because you do not have either negatives or fractions, because you do not have an end point. Okay, so for these ones where we have end points, in most cases we utilize the combination. So utilize the combination part of it only and only when you have positive what? Positive integers. That is the first thing that we are looking at. Then, in the next one, for this one here, now this I said before that, we are saying that these ones we are using the what? These ones are for positive what? For the positive integers. This one and also this other one here. The n, which is the power, of course, the power is a positive. That is what we are looking at. Okay, that's what we are looking at. So once our power is a positive n, that means we are going to utilize this to here. Now for the other one here, now look at this one here. We are saying for any rational value, where we are looking at the integers or the fractions. Now, this one here works for all of them. Okay? This one here can only work for all, but specifically for negative powers and fractional powers. Okay? For negative powers and the fractional powers. So that's why I am saying that for this one here, you can use both the positive integers. We can also use the fractional powers as well as the negatives. But primarily, it is basically taking on the negatives and also the what? The fractionals. Now, why are we taking on this one and not using the other? You see that this one has no combination. And earlier on, we are saying that fractions and negatives are not taking on the what? The combinations. Okay? Where you have any combination. These ones do not take on that. So that is why, even when you get them and utilize this one, it is going to work out for you. We are going to check on different examples. So in a summary, we are saying, let me summarize it here. So we are saying in a summary, when we have this, let's rub off this. So in a summary, we are saying when we have, for example, 1 plus x to the power of n, we are saying this one is 1 plus nx plus n into n minus 1 out of 2 factorial x squared plus n into n minus 1 n minus 2 out of 3 factorial x power 3 on and on. So we are saying this one is universal. Okay, here it can take on, but primarily it takes on both we have the negative powers. It also takes on the positive integers, and it also takes on the what? The fractions as well. Okay, for this one here, that's what we can utilize. Now, for the other one, where we are saying that if you have a plus b to the power of n, we are saying summation from r equals to 0 to n combination r, where we have a, n minus r, b to the power of r. Okay? Or we can also write it as 1 plus n combination 1x plus n combination 2x squared plus n combination 3x to the power of 3 plus on and on and on. So these ones here are working for, only and only positive what? The integers, okay? They are only and only working for the positive integers. This is something I want us to put into perspective when we are working out a certain number. I have some hand up. Yes, Joe. Sorry. Yes, Bridget. Your hand is up.
Teacher, I'm sorry for taking you back, but I wanted to ask, like, the previous assignment, the one you gave us, is it okay if I just do up to x squared?
It is okay.
And
what did the question tell you where to stop?
Yeah, it was like as far as the term in x squared.
Yes, that means you're supposed to stop at x squared. That's what it means. Noted?
What if I do up?
What if you do what?
I do up to x cubed. Is it wrong?
Why? It is very wrong. It is very wrong. You're being told it is wrong because you're being told to end at what? At x squared. Don't go beyond.
Okay. Okay, sir.
All right. All right. So we are going to do a couple of worked examples, and then we shall be able to see how the two work out. I don't know if there is any question as far as this, because in the previous question in the previous lesson, we're so much into when do we use this, when do we use the other, and so on. Okay. So what is dictating is this one here. What is dictating is this positive integer here. That's what is dictating mostly. But all the questions that we are going to get, we need to put them in this form here, okay? You need to put them in this form of 1 plus x, whatever the form will be, okay? So if you are given we are going to do some bit of worked example, and then we can be able to work on that. Now, in the case, maybe another thing that we need to watch out is, in your case, you are given an equation in the form, look at this form here, a plus.
Excuse me, teacher.
Yes, please.
Excuse me, teacher. Teacher, is this second formula the same as the third formula? Like they are both for the positive integer. I'm asking, is this second formula the same as the third formula? Because they are both for positive integers.
Yes, these ones are fine. They are both for positive integers.
So I can choose to use either of the two.
Yes, please.
Okay, thank you, teacher.
Okay. Yes, Melissa.
Teacher, I thought the first formula is the same as the lower one, but the powers differ. The first one has a negative power, and the third one.
They are not the same because the first one has no combination. Okay.
No, like I'm saying it's bracket 1 plus x, and also just that the formula you use to attempt it depends on the power. But then the second formula is a plus b power n.
Which one are you talking about? This one?
Okay, teacher, you write what's in front of the last bracket.
Oh, are you talking about this?
The third formula.
Oh, this one here, yes.
Yes. What is in front of the bracket?
It is
Isn't
x.
it? not this, like before the formula, and she's supposed to say bracket 1 plus x power n is equals to 1 plus n combination 1x.
I'm not getting what you're saying. Maybe let's get back to this. We are here. Is this what you're talking about?
Yes, you're saying that the formula there has 1 plus x per n is equals to that formula. Even the first one, then is the same, but just that the n is negative.
Even this one
the
here.
Second, yeah.
No, what we are
Whereas
saying,
the second
no, you first hold on. What we are saying, okay? When are you supposed to use this one here? Much as we are saying we are specifying that this n here, for this n here, it is a rational number, okay? Meaning we are considering this one here mostly for the fractions, okay? Because fractions don't take on combinations. That's what we are trying to do, okay? I know someone might say, what is one combination and a half? Or you say one combination negative 2, okay? This is what we are trying to, negative something. This is what we are trying to avoid in this first combination, in this first formula. So in so doing, you cannot utilize this one here. We have to substitute into this to avoid this other part here. That's what we are trying to look at. So that's why we will say that our n will be just being subtracted through to come up with what you are having here. But for this, in case you have, like if you have your a plus b maybe to the power of 2 or to the power of 6, literally when you substitute into this, you'll be able to use the combinations to come up with your answer, to come up with your result. Okay, yes, Emma.
Teacher.
Yes, Emma.
Yeah, I just want to inquire, like now the example you gave, like that one of one combination negative 2, how do you combine it?
Pardon?
That example you have given, that one of one combination negative 2. How will you combine that one?
Okay. Now, another thing, maybe something that we need to put into perspective is this one here, you can utilize all of them. This one, as I said, this one can take on both, all of them. Whether you have, even if you have something to the power of 2 or to the power of 3 or to the power of 4 and so on, this one is universal, okay? This one here, it is the universal, maybe let me round it up. This one is universal, okay? It's a universal formula that you can substitute any. But this one here, you cannot bring in the fractions here. Okay, so this one here, we cannot bring in the what? The fractions here. This one specifically will work for our positive what? Integers. That's what we shall utilize specifically. But why would you come and utilize this one and yet you have this universal one whereby you can do any substitution, whether you have negatives or you have the fraction, you can still utilize this one. This one takes on all. Okay, that's one thing we should know. But at the end of it all, the result that you're going to come up with, it is going to be in the same format. We shall not get a different format. We are going to do our example and then we say, you realize that the example at the end of it all, it will come up with the same format of the result. Okay, the same format of the result. The format will be the same. But at some point, we are going to see where the difference is. I'm going to give you a given example, and you'll see that when you utilize one of these other ones, you will not be able to come up with the same thing. Yes, Emma?
Sir, does that mean that for any given question, we can use the first equation?
Definitely.
For any question.
For any given equation, you can utilize this one. It is very, very fine.
Okay, sir.
Okay. Okay, I think that answers yes, Bob.
Teacher, but I thought you had said that the negatives and the fractions don't take on the combination.
And it is the reason as to why we are taking on this one here. It is the reason we are using this.
Okay.
Do you see any combination in this equation here? This equation has nothing like a combination. Yes, so that's why we are utilizing this.
Okay, thank you, sir.
Okay. All right, maybe let's do a worked example. It will really bring out, maybe I was trying to say something. Yeah? I was saying that if you have a question, sorry. Started at the wrong note. Anyway, I was saying that if you have a question in this format, maybe you have bx, sorry, let me write it, a plus bx to the power of n. Now, I'm giving this, for example, if you have like maybe 2 minus x to the power of 4. I'm comparing this. Now, when you have this question in this format here, what are we supposed to do? We are supposed to put it in the format of 1 plus x to the power of n. Okay, that's the format we need to put our results into. So when you have this one here, put it in this format before you start expanding, before you carry on the expansion. So in so doing, like for example, here what we shall do, for example, we can now first simplify this one here in this format here. That's what we need to focus on. So when I have a plus bx, this can be the same as a, we pull the a outside. What is our aim? Our aim is to remain with 1 here. That's our aim. So we shall have 1 plus, I think this will be out of a, x. Yes? When you bring the a into brackets, you come back to this one here. What is our aim? We are trying to ensure that we have our equation in this format here before you start using the binomial theorem. Okay? Before you start using the binomial theorem, we need to first put it in that given what? In that given format. So when you have this, it will mean that remember we have our power n, meaning our power n is going to be here.
Excuse me, teacher.
Please, can you first mute? First mute. We need to first follow. Okay, so here we shall have our n. Remember the n has to be both on this other one and this one here on the a, because this one has been also been simplified in that form. So therefore, you'll have to now simplify this one here alone, and then you multiply it by a to this given what? This given power. Okay, that's what we need in case you have such questions in this given format. The point is, first try as much as you can to simplify it in this given format of 1 plus x into the power of n. Whether the n is a negative or it is a positive, it doesn't matter. But what's more important is for you to put it in this given format. So meaning your x will be b out of a x. This will be now your x, and this will be your 1. So we put it in that. Once you do that, we shall have a to the power of n, 1 plus b out of a, x to the power of n. So from here, you now simplify this. After simplifying it, you multiply it by a to the power of n. That's what we first carry on. Can we do a worked example? Do we do this on all the formulas? Yes, we do. Okay. Yes, we do. That's what we do. I think Benjamin has worked out this one here already. So in the case, sorry, let's have our page here. Sorry. So in the case you have this, if you have 2 minus 2, maybe 2x to the power of n. So first put this one in the format of 1 plus x to the power of n. This is the first thing you need to do. So in so doing, you'll end up, you can pull out the x. So, sorry, this was x, I think. This was just x. Okay, I think this was just x. So this is minus x to the power of n. So what do? You put the 2 outside into 1 minus, this will be a half, a half x. Okay, into that to the power of n. So literally, we are going to simplify this first, and then we multiply it by 2. Now, where trouble comes in, learners forget multiply whatever they have expanded by this other value which is outside. Please don't forget that. Otherwise, if you're told to do substitution at some point, you're going to get the wrong result. Okay. Now, take note that when you're carrying on the calculation, your x is negative a half of a half x. This is your x. Don't just take it as a half, because we have a sign here too onto this other one here. Someone might also write it into 1 plus negative what? A half x. This is the same thing, the power of n. Okay. If you want to show that it is a plus, so it will be in that given format as well. Okay. The power n varies. Okay. This power n varies. The n can be, remember our n, I'm keeping it as a constant n, but n can be a positive, it can be a negative, it can be a fraction, but all in all, we need to make sure we keep it in that given format of that. Yes, Joshua, may get something from Josh. Sure.
I think that coefficient of 2 is it is power n.
Pardon?
This 5.
Oh yeah. The 2 is also power n. True. Yes. Very true. Good. It's also n. Thank you. Okay. Yes, Emma again. Emma.
So I remember in the previous exercise, you gave us some number. Now, like for example, if you have square root of 12, how do you express it in the form of 1 plus x?
You have square root of 12.
Yes.
And you put it in this format of 1 plus x.
1 plus x, yes.
Okay, so get a value whereby you can, like, we are looking, this will be the same as 12 to the power of what? Power of a half, right? This is 12 to the power of a half. So here, you know that automatically you're going to have a 1 this other side. Okay? Plus, or even minus, of course, depending on what if your equation, if what you were expanding was a minus, then you're going to put a minus. Okay? Then the minus, what value are you going to put here? So that you're going to get 12. But when you subtract, you're going to get 12. I think this will be 13. Okay? So this will be 1 minus 13, the power, and then you do the substitution. If it is this one here, if it is in this given format. So what we are looking at, if you have something in that given format, at the end of it all, you are going to express it in the format of the original expansion that we had. But take note, sometimes it's minus, sometimes it's plus. Sometimes it's minus, another time it's plus. Okay? So take note of those variations at any moment. Now, let me do a worked example. There's something that I gave you at some point. Okay. Maybe there's some question I gave you at some point that I think we should work out. We are here. I have about the, okay, let me check through. There's this one here that I gave you. I think it's this one here. We remember this question here. I think this is what I want us to we are going to work out this. And then we try to see how best do we express that given question. As far as the binomial theorem is concerned, that's what we are looking out for. Okay. Now, so we are saying expand the root of 1 plus x over this in ascending power of x. okay, up to and including in the terms of x squared. Now, this means that we are going to stop at what? We are going to stop at x squared. There's someone who was saying, what if they ask for x squared and me I go up to power 4? That's you're already answering your own question. Meaning we are going to stop at what? At x squared. That's the first thing we need to do, the expansion we need to have. So, I think, let me get space here. So we are saying that if you have the root of 1 plus x out of 1 minus x, put this in terms of powers. Okay, first thing, put this in terms of powers. This was the same as 1 plus x to the power of a half out of 1 minus x to the power of a half. This root means a half. Okay. Now, we're also not going to solve this one like this, meaning we're also going to express it in a multiplication form. We are going to stretch so that we do out with the divisions. So this will be the same as also 1 plus x to the power of a half into, when we bring it up, it becomes a negative. So it will be 1 minus x to the power of negative a half. Now, literally, when you're doing in mathematics, in your calculation at A level, this is, you've not gotten even a single mark here. Okay. Can they ask up to x to the power of 4? Yes, they can. Yes, they can. It is possible. I'm not saying it's not possible, but we need to stop where they've told us to stop. Let's not. We don't go beyond. Don't say, now I want to go up to power 6. Now the expansion will be too large. It will be such a large expansion. So that's why at the end of it all, we stop. We have very small expansions. The largest is always to the power of 3. The largest is the power of 3, but usually power 2, power 3, power 2, power 3. So now, what do we do from this point here? From this point here, what we do, we now expand them separately, and then we multiply afterwards. Okay, so meaning you're going to expand this one here, 1 plus x to the power of a half. Okay, and now we know what we are supposed to use. By now we know what we are supposed to be using. We are going to use the one of 1 plus nx, n into n minus 1, 2 factorial, x squared plus n into n minus 1, n minus 2 out of 3 factorial, x power 3, on and on. Please don't forget, don't just stop here. Please add the plus and you put the dashes. Means the equation is continuing. We've just stopped where we've been told. The equation is continuing. So those of you who have done the substitutions, can someone give us a substitution here? Let me request someone to give us a substitution here. Joshua?
Joshua? I'm not giving the substitution.
Oh, you're asking
the equation.
Yes.
In the first equation, after 1 plus nx, there is another plus.
Here there is a plus. Yeah, true. All right. Someone giving us the expansion? Emma?
So, okay, the expansion is from that part where I stopped. It is 1 plus x over 2.
X over 2.
Plus negative 1 over 4x squared over 2 factorial.
Negative?
1 over 4x squared.
Over
2 factorial.
2 factorial.
Plus 3 over 8x cubed.
8x cubed.
3 over 8x cubed out of 3 factorial.
Out of 3 factorial.
Yes, then plus continuous.
So when we do the substitution here, this we shall get 1 plus x over 2. This will be minus. This will be minus. This will be 2 factorial times this. It will be 1 out of 8, I think. Be 1 out of 8 x squared. Please work out this one here. Don't this 1 out of 16. 3 factorial will be 3 times 2 times 1. Eh? That's what, so meaning we shall get 3 times 3 times 2 times 1, which will be 6. Okay, so when you bring through, we shall get 16. Eh? When you take it up, x power 3, on and on. Yes, Joshua. Josh? Yes, Joshua?
So you guide me how to calculate and solve those.
How? Now, factorials, you put it in your calculator. Put it in your calculator and you say 2 factorial. Or we know that 2 factorial is the same as 2 times what? 2 times 1. Eh? If we have 3, we shall have 3 times 2 times 1. So you multiply whatever is behind that given number. That's how you get that. Okay, so that's why when we get this, we shall get 2 factorial is 2. Okay, so meaning you're going to have, you're having 1 out of 4. When you bring it up, it comes times 1 out of 2. So when you multiply, you come up with 1 out of 8. Got it? Okay. Hey, please, we are in A level, so there are some simplifications that I really want us to get a side paper, get some paper somewhere, and then you try to engage. Get somewhere, and then you try to come up till we get to this given point. So this will be for 1 plus x to the power over half. Okay? So we move on. For the next one here, we have this other one. We have the other second one, 1 minus x. So we shall also have 1 minus x. Please, the 1 minus x to the power of negative a half. It is negative a half. It is not a half. Where is the negative coming from? It's because we brought this one up. When you bring it up, it becomes a negative. That's how we came to that. That's how we did it. Okay. Can someone else try to get us the simplification of this? I'm sure some people have done. We are working out together. Oh, yes, Emma.
We have 1 plus a half x.
1 plus a half x. This is x over 2.
Plus 3 over 4x squared, 2 factorial.
Plus 3
over 4x squared.
X squared.
2 factorial, out of 2 factorial.
Out of 2 factorial, okay.
Plus 15 over 8 x cubed.
15 over 8 x cubed.
Out of 3 factorial.
Out of 3 factorial. Okay. Someone else to simplify it further from here. Now I'll ask hey, Benjamin. Benjamin has been so quiet. Benjamin, you've been so quiet. What's happening? Are you working out with us, Benjamin? Why, Benjamin?
Yes, sir.
Please help us here. Simplify for us further from here.
Good morning, sir.
Good morning.
I was still working out.
Hey, you're still working out, eh? Okay. All right. Another person too? Wesonga has been quiet also today. Yes, Wesonga. Okay.
Sorry, good morning, teacher.
Yes, good morning.
Okay, the final expansion is 1 plus x out of 2.
1 plus x out of 2.
3 out of 8 x squared.
Plus 3 out of 8 x squared.
Plus 5 out of 16x cubed.
X cubed. Okay, thank you. People are keeping quiet there with the quick answers. Okay, so now when we have these two, we are going to now combine. Okay, we are now going to combine the two. So we have these two equations here. We have this one. Okay, we have this equation and also this other one. Now, the last thing that we are supposed to do is to multiply. Now, this is where the challenge might come in from. Some people say it was too large to be expanded. So here we have 1 plus x over 2, okay? X over 2 minus 1 out of 8, x squared, plus 1 out of 16, x cubed, okay? We are multiplying it by 1 plus x over 2 plus 3 over 8x squared plus 5 over 16x cubed. Of course, there are those plus and so on. Eh? These are the two things we have. Yes, Bridget, your hand is up.
Teacher, the second equation. This one for Westonga, isn't it 1 plus x out of 2 minus 3 out of 8? Because remember the x is negative. Yeah, so I think it's supposed to be minus 3 out of 8 x.
It's negative, but remember it's also multiplying by another negative here. That's where I think the positive part is coming from. Eh?
Yes, teacher.
It's multiplying by another negative. Remember, this one is negative. This one is also negative.
Yes, teacher, but the second one, the one for Westonga.
Yes, and we are substituting. When you do the substitution, you do the substitution from this one here. So in here, we are saying it is negative a half into negative a half minus 1.
But the x is negative here in the second one. It's 1 minus x power negative a half.
No, our half is what we are multiplying. We're substituting from here. N, we are looking at n. Leave the x alone. The x is this side. Eh?
Okay.
Yes, the x, remember it is squared.
Yeah.
And it will be a positive. It will turn to positive, right? So meaning it will leave this one here negative. That's how it comes.
Okay, thank you, teacher.
Okay. So please, I request that as we walk through, you try to prove, you try to prove through so that you come up with the right thing. Okay. Yes, Benjamin.
But Sai had told us that when we have 1 minus x to power n, it's like having 1 plus into negative x.
Yes, that's what we've done. Yes, very true.
So it means when we have here x squared, it means it's negative x squared, isn't it? That 3 over 8, that's the negative.
What is negative x squared, Benjamin? Benjamin, what is negative x squared?
Negative x squared.
Yeah.
I think it's x squared.
It is x squared.
But if it was like that, well, how about x cubed? Negative x cubed.
It becomes now, it is now different. But remember, now, much as we have this one here, look at this other one also. There is something we are not looking at. Eh? Look at this one also. Yeah? Do you see this? This one also affects, once you produce a negative here, it will definitely affect the entire thing. Okay? It will affect the entire thing. It is not independent. Eh? It's also, it has some attachment on it. Okay. I think we got it. Please, this one is now our simple calculations of this arithmetic that we have. It's basically that simple arithmetic that we need to work through. Okay. I still have questions here. Emmanuel?
Yes, teacher.
Yes.
We have a constant in the second equation.
Yes.
Last step. I'm seeing 15. 15 over 8.
So we have 15 over 8. X is okay.
The 15 is where my constant is. Where did it come from?
Yeah, where did it come from? Have you done the substitution here? Have you done the substitution?
Okay.
Thank you. Please do the substitution here. This is where we are getting our challenges from. Let's do the substitutions here. Clearly. Okay. I think he has got it. Yes, Joy, finally. Then we calculate this. Okay. Okay. Jay is off. So
can you hear me?
Yes. Okay, you're off. Now, dear members, let's finally look at this. So if you have this, how can you easily, we are winding up, how can you easily solve this one here? I know someone was saying it is a very long thing. Now, what you do is this. Multiply, we go one by one. Like we get this one, multiply it through by this. Okay? Okay? Get your one, multiply by this. You put them on separate lines. Then this one also on its own line. This other one on its own line like that. So this is what you're going to get. You're going to get 1 times the 1, which is 1. Okay? Plus 1 times this, I think we shall get x over 2. Still 1 is multiplying by that, plus 3 over 8x squared, plus 5 over 16x cubed, plus on and on. Okay? Now, for the other one, we bring it down. So you again start saying x over 2 times 1. You'll get x over 2. So you bring it to its corresponding. We have our plus sign here. We bring it corresponding here. So we'll be x over 2 plus. But remember, our equation is ending at what? X cubed. Yeah? That's where we are adding. So when you get answers like x power 4, when you got x power 6 and so on, those ones, we leave them out and focus on where x cubed is. That's where our main focus is. So we continue. Then you get x, we get also x over 2 times, we multiply this by this. Then this one times this times x over 2. So this will be x squared over, or we can even write it in the same format. We can put it in the same format maybe. This will be, I think this is 3 out of 8. I think. So this will be this times this will be x squared over 4. Okay, x squared over 4. This is the same as 1 out of 4 x squared. This is the form I wanted us to write it in. So you see that we are going to follow them in that corresponding order. Then you continue plus. Still we are here. Okay, x over 2 times 3 over 8. So we have here our x over 2 times 3 over 8, maybe 3x squared. So here we shall get 3x cubed out of this times 2 times 8, we shall get 16. Okay? And so on and so on, plus these ones are no longer needed. Okay? Because we are ending at what? At x cubed. Does anyone following who can give us the next one? Anyone following to give us the next one, the next expansion? Someone following to give us the next expansion? So the next one, we are moving to this one here. So it is now this times 1. Yes, Joshua is following. Yes, Joshua?
Now we are to get negative 1 over 8x squared times 1. And we get negative 1x negative squared.
1 out of 8.
Yes, x squared.
X squared, okay.
Then plus we get the 1 out of 8x squared, which is a negative. We multiply it with x over 2. We get negative x cubed.
It's negative, okay. This is also negative. Let me remove this. So this is also negative.
Yes, we get negative x cubed.
X cubed.
Out of 16.
Out of 16. Or you can
stop from there since we wanted only the x cubed term.
Or we can write it in the format, maybe in the same format. We can say it is 1 out of 16.
Yes.
X cubed, okay, plus
yes.
on and on. Okay,
so we have got the x cubed.
Good. I don't know if we are getting the format, how we are coming on with our expressions. Emma?
So I just wanted to talk about the next one.
Oh, thank you. Good. The next one will be?
The next one is plus x cubed over 16.
This is x cubed over 16.
16.
Which is 1 out of 16 x cubed.
Yes, plus
on and on. Thank you. So from here, you now total up. You now add. You add up. Okay. So when you add up, this is what you're going to come up with. So you'll see this, that 1, when you total up, the 1 remains here. Plus, okay. This is what we are moving on with. So plus, what shall we get here? I have natural Ida.
Good morning, sir.
Yes, good morning. Okay. You wanted to say that? Okay. Let's move on. Hey, our class is done. Our class is done. Our time is fast spent. Yes, Joshua, maybe Bob.
So there we get x.
We get x.
Yes.
Just x.
Yes.
We have x over 2 plus x over 2. So it becomes x, eh?
Yes.
Good. X, plus. Then when you come to this, okay, you can maybe prove out this. Then here we shall have 3 over 4 x squared. Then plus, because of time, 9 over 16. This will be x cubed. Now, we just follow this, then you'll come up with a final bit of it. Now, what I wanted to put across was the point of us trying to be able to add up when we have those values. Don't start expanding it. You get x power 4, power 5, and then at power 6, and you'll end up struggling through. So what we look at what we need first. What we need is to end at x squared. So we try to put it in that given order. So from there, we shall be able to get our final expression in that given format. So that will be our final expression. So when we have, therefore, we can say the root of 1 plus x over 1 minus x is the same as 1 plus x plus 3 over 4 x squared plus 9 out of 16 x cubed, on and on. Okay. Now we've been told that if we have we are still just something small. by substituting x, okay, by substituting x is equal to 0.2. So for x, you put 0.2. Where there is x, put 0.2. Where there is x, you put 0.2. So see what you'll get. So when you have this, we shall say root 1 plus 0.2 out of 1 minus 0.2. Members, when you have this, the 0.2 is substituted here, okay? You put your 0.2 inside that equation there. That's what you do. So when you put your 2 there, it will be equal to 1 plus 0.2 plus 3 out of 4, 0.2 squared plus 9 out of 16, 0.2 power 3. Okay, 0.2 power 3. So you realize that in the deduction, when you reduce this one here, that's why that's why you see, find the approximation of the root of the root of 1 point, the approximation of the root of 1.5. So meaning in this one here, when you have the root 1 plus 0.2, we shall have 1.2. Out of 1 minus 0.2, we shall get 0.8. And when you divide 1.2 by 0.8, you come to 1 point what? We shall have 1 point, and it's 1.5 when you walk through. I hope we are still working together. Divide by 0.8, we shall get 1.2, okay? So, sorry, 1.5. So this will be equivalent to, you do the substitution here and you get your result. Whatever result that you get there will be our final answer. So when you substitute here, you should be able to come up with this is 1 plus 0.2 plus 0.03 plus 0.00. This is 0.0, around 0045, I think. Okay. So finally, you'll have come up with your final result for 0 point, getting the root of 0.5, which will be 1.2345. Okay, but there was someone who was doing, please, when you're doing the answer, do not, when they say do the substitution for this, don't again go back up. Just use this final equation. It means that what you've got here, use it, and then you come up with your final what? You come up with your final answer. That's what it means. Don't again go back and do the substitution from the up. Do the substitution from here, then you get your final result at this given point. That's what we do when we do the part of deduction. There was someone who was asking, how do we deduce? How do we carry on the deduction? But in the deduction, we're just doing the substitution. When you substitute for x and you carry on the division, you should be able to come up with that given deduction that we are asking about. Okay, I have so many questions that we can discuss together, but time. Yes, Bob. Bob?
Sorry, teacher, I think I left my hand raised.
Okay, okay, it's okay. Okay, Martha?
Sir, please may I just review the question very well? I had not seen it very well.
Oh, but you saw the solution.
Yeah.
All right. Okay, okay, so I think we've seen this, how we can really carry on the deductions and this. This is how we can really come up with our deductions. So in case you have a challenge, then that's how you're supposed to run through it. So when we have these other questions here as well, you can now see, okay? When you have this one here, you see, here we know we are going to first put it on in power half, 1 plus 5x, put it, this is power half, 1 minus 5x, power a half. So you do separate expansions and then you multiply. So whatever you're going to get, you're going to substitute this into this. When you carry on, when you do the substitution, you're going to come to root 14. When you substitute 1 out of 9 into this, you're going to come to you're going to come to root 14. So when you do the substitution, you're going to come up with it. So in case you have any of these questions, even this one, we can carry on the same format, okay? When you check through the questions, they are going to ask us, first carry on the expansion. Someone was asking, can we go up to 4? Here, we are now here at power 4. Here we have up to power 4, okay? So when you do the substitution here, you'll be able to come up with your final result. So this is how you do, when you come across most of those questions, that's how we're going to work out. Yes, Penlock, finally. Naturenda.
Teacher, this is all we do when they tell us to expand. Eh?
Yes.
Sometimes they tell us to look for the coefficients, and as if there is some formula that we use.
Now, when we are to find the coefficients, we utilize the very first formula. Like we use the other one of the summation. Eh? If they say, actually, there's a question I saw, I put here also, where you're supposed to find, maybe finding the independent values here. Here, you use this function here, r equals 0, and any combination r, then b, n minus r, sorry, this is a, like this. So what we are doing is we do the substitution here. That's what we are doing to get the independent values at some point. But the point is this one here helps us to find the coefficients at the end of it all. Okay? This is what helps us to find the coefficients. I have so many of them. Okay, I've worked out most of them that I'm going to share with you. Actually, when you check in your Google Classroom, check in your Google Class, I'll try to post most of them and you can try to work through. Now, this is what I also wanted to look at. You see, when you have this, put it in a form of 1 minus x, okay, power n, where we say that this will be 2 to the power of 6 into 1 minus a half x. This is also the power of 6. So when you expand this, multiply it by 6 to the power of 6. If you just do the expansion and you do not multiply, when you do the substitution, you're going to get a wrong result. Okay? So make sure here when 6 to the power, I think it's around 64 times whatever is inside there, and you come up with your final result. That's what you're going to carry on. So you see that when you utilize that formula, it's going to really work out for us. Okay. Yes, Ashwinda? Okay, I think we are done. Yeah? Okay, I think I've posted this, yes?
Does it mean when I'm also looking for the coefficients, I have to first put the question in form of 1 plus x power n when I'm looking for the coefficients?
Yes, that's what you're going to do. Yes, please. That's what you're going to do.
Oh, okay.
Now, the coefficients are these values here. Maybe the coefficient may be the term, but when we ask the coefficients here, like in the equation here, the coefficient of x squared is 3 out of 4. The coefficient of x power 3 is 9 out of 6. So these are the coefficients that we have, or that we are going to work out. Here, the coefficient of x is 1. Okay? So if they tell you to solve and then you find the coefficients, you just pick out those coefficients that you do have. Okay, dear members, let's stop here. Check in your Google Classroom. These worked examples are there. And I think once you have those two formulas with you, then I'm very sure the rest is fine with that. Okay, unless there's a final question. Unless there is a final question that we need to look through before we close. All right, okay, thank you so much for being part of the class. Those who have just joined in, Please follow up with the Google Classroom. You'll be able to get the result, the other lessons and the tutorials that have been there. I've already posted the worked examples and what you're going to work. Now I've put a list of various questions that you can work out only on binomial theorem. When you go to assignments, you'll see. But for this lesson, you can only answer only 2, and then you forward. You send them through the Google Classroom. I can look through. But I think there are over 20 questions. Please practice them out, and it will be good to go. You have the formulas with you, and then you can now manipulate them, and you'll be able to work through.